Internet of Things Conference, Mobile Tech Conference hier in Berlin. Wir haben für das letzte Interview des Tages mal kurz die Location gewechselt und befinden uns jetzt in einem sehr spacigen Galeriebereich des NH-Hotels hier in Berlin. Bei mir sitzt der Tim Geurtjens. Hallo Tim. Tim ist CTO von Joris Laman Labs und Co-Founder von MX3D. Das ist ein Unternehmen, das industrielle 3D-Roboter herstellt, 3D-Druckroboter herstellt. In die Medien gekommen ist das Unternehmen vor kurzem mit dem Plan, in Amsterdam eine Stahlbrücke über eine Gracht zu drucken. Wir werden ein bisschen über das Projekt sprechen, zuvor aber ein wenig erstmal über 3D-Druck an sich reden. Tim, we'll switch to English now.
Okay.
The state of 3D printing right now, in the last years, especially the prices for consumer printers have gone down, way down.
Yeah, drastically.
At the same time, you said like the output or also the choice of materials didn't. Why?
Yeah.
Why? Do you have any explanation for that?
It's hard to explain, I think, to find an actual reason for that. It's kind of what we noticed. There's more 3D printing materials coming, and there's a lot of developments in it. But maybe the rate of the drop of the price for consumer printers is so high that the materials just can't keep up. Mm-hmm. And we started as furniture designers, so for us material is really important. Material and building volumes. So not just materials, but building volumes, printing speed, and maybe even most importantly, the price not for consumer printers, but for more professional printers that could actually print better quality products.
Okay.
So.
How many materials are there right now? Can you give us a ballpark that you can print with? Different sorts of plastics, of course. Metal, of course.
Metal,
too.
of course. Yeah. We're not the first ones to print in metal, but there's a lot of metals that can be printed. But also, plastics, plaster, stone kind of materials. Mm-hmm. There's quite a lot of materials, but most of them don't really. The only really good material for us, really nice material, is metals.
Why?
That's what we. Because if you want to make something nice, something beautiful, you need a beautiful material. Mm-hmm. And I mean, if you print in plastics, most of the plastics you can print don't really look nice. It's plastic. You can make iPhone cases with it, it's cheap and it's quick. But I personally don't really like those materials, and it's not really strong as well.
Mm-hmm. What about the future of 3D printing? Where do you see it evolving on the industrial side and also on the home side? Where do you see it going?
Well, first of all, the home side, a lot of people think that in about 10, 15, 20, 30 years, everybody will have a 3D printer on their desk. I don't really think that's the case. People couldn't be bothered by actually putting the printer there, learning a CAD program, printing something, waiting for it. It's going to be inferior materials, I think, for a long time. And it's just as easy and cheaper to order it online at Amazon or whatever. You have it within a day. It's cheaper and better. So I don't think people could be bothered. But I do think that 3D printing in an industrial environment is going to grow hugely. Mm-hmm. If the printers become better, materials become better, it becomes cheaper, then I think there's a bright future for 3D printing. In almost every field of expertise, how do you say it, almost every industry, but different parts of the industry, I think.
Mainly, or not only mainly, but very interestingly also, I guess, medicine or organ printing?
Yeah, that's really interesting, yeah.
Okay. Let's turn to the bridge now.
Yes.
How did this idea to print a bridge come about?
Well, we were working on this technique. We've been working on it for a while, and we got in contact with Autodesk, the software company, and they were supporting us from the beginning before we had the bridge ID. And then we were visiting them, and the night before our visit, we were thinking about we have to present something. We have to tell them something. What are we going to do with it? And then almost automatically the idea of the bridge came about, because that's that's typically something you can only print with a technique like we have. It's steel, it's big, it's not within a bounding box, but outside the box. So it kind of all came together, the symbolism of connecting an old city like Amsterdam which has a lot of canals and bridges and water. It kind of came naturally almost.
How does the printing of metal differ from the regular printing with, let's say, with the normal printing with polymers and stuff?
You need a lot more energy to print metal. To melt plastic, you do that with 60, 70 degrees Celsius, maybe 80. And the steel we print, you have to melt with 1500 degrees Celsius. So you have to put in a lot of energy. Plus, if you print metal, you need a shielding gas, because when you heat up the metal so high temperatures, then it tends to react with oxygen and tends to burn. So you need a shielding gas. So the whole process is a little bit more complex than plastic printing.
Okay.
We found out.
Are you going to print the bridge on site at the Gracht, or are you going to do it in the lab in a special environment?
Preferably on site. It depends on a few things. It depends on the final location where we're going to print it. If we are going to do it in the most busy area of Amsterdam, then it's going to be practically really hard to do it on site, because then we would need 24/7 security. There's too many people who can, ride horses on the robots that are standing there. So I think that's a little bit too dangerous. But also the technical side. We have, of course, a limited budget. The whole project is financed by our partners and sponsors. So, and it's a lot more costly to do it on site and to do it live than to do it live in our test facility. Okay. But that's what we want to do anyway. We have a test facility in the north of Amsterdam, and we want to print the bridge live there. And if it's possible, we're going to do the second bridge, like not the prototype, but the real bridge on site.
On site. How much convincing did you have to do with the city of Amsterdam?
Not too much. Having said that, we don't have a final location yet. The project in itself, they were really enthusiastic about it. They saw what it could bring to Amsterdam, to put Amsterdam on the map as innovators, as an innovative city. They profile themselves as a startup generator almost. So, I mean, a project like this they really want it. But the location, if we want to do it in that center of Amsterdam, really in the center, there's problems. I mean, it's World Heritage, UNESCO World Heritage, so we have to see.
It's tricky. Okay. You mentioned Autodesk, your partner.
Yeah.
Can you tell us, because it's mostly developers watching this, can you tell us a bit about the software side, the technologies you're using?
Yeah, sure. The technologies, well, we started out with existing software to drive a robot. So we just downloaded something, student license of a program, and we worked with that. It wasn't enough for us, so we started developing ourselves. And we do that together with Autodesk. And Autodesk is helping us to, on the full length of the software. The whole software development is quite complex. It's not just about driving the robot. It's also about the parameters the printing parameters, so to say. For everything we print, if we print horizontal, vertical lines in different corners, it's all parameters we have to find out, we have to test, and once we test it, we have to manage that in a software. So all that has to be linked to a CAD software. Okay. And yeah, I mean, we are still fully developing it, but it turns out to be a bigger issue than we thought in advance. I mean, yeah.
So what's the roadmap? How long are you going to test, and when are you planning on really printing it?
Well, the next 8 months to 1 year, we are going to test in our test facility in the north of Amsterdam, and that's also going to be really open. People can just come by, have a look, see what we're doing, and then we're going to fully test the capabilities of our technique. We know we can print. We know we can print big stuff. But we want to explore the full limits of what we can do, and then take one step further, and then based on that we're going to make the design of the bridge, and then after that we can start printing. So I think if we actually print on location, we will probably start beginning of 2017.
Okay. You mentioned limits of what you can do. What's the limit regarding detail of the bridge, like decorations or anything? What can you accomplish on this side?
Yeah, I think we can accomplish quite a high level of decoration, of detail. Of course, less than most traditional techniques, because they really focus on detail, on accuracy, on layer height, and that's kind of stopping the development of bigger printers. And for us, it was more interesting to make bigger printers. And since we want to use these this technique for bigger structures, like in architecture, you don't need as much detail as you would need printing implants or printing rotor blades for engines, for jet engines or something. So we kind of focus on scale rather than on detail.
Mm-hmm. Tim, a very interesting project. I'm looking forward on the progress, and we'll get back to you once you've printed it.
Yes,
at the
thanks.
latest.
Yeah,
Thanks
that'll
for
be
taking
great.
the time.
Thanks.
Bye.